Hello everyone, welcome back. In this part of the tutorial, we're going to be focusing on creating our second block. We're basically going to continue on creating a tower. Where we left off from the previous video is we created nice previews of our first block, as you can see on my screen. And what I did afterwards was basically just group these components together and give it a nice bluish color. So let's set down what we need for this part so that we can continue on working on our script. So what do we need? We need to build the second part. Obviously, we know that. We know how it looks like. It can be any part of we know that there is one of these that's eliminated. So the outline is probably going to be something like that. Oh, no. Should probably draw like that, I think. And what I want to do is we have these three columns as data. I probably should pick a different color. We have these, right? We have those three columns, and we also have this because this doesn't really change. So what we need to do is we need to focus on the columns that resides on this part, which is the new curve for us. And if we look closely to an example, like what they have, so if you Google image search for World One floor plan, you probably come across all of these, and you'll find this one among them. And as you can see, there is a lot more column, obviously, on the longer curve. So what we're gonna do is we're gonna start looking at what can we use from block one that can define our columns for the block that's above it. First and foremost, we're gonna select the block select. Obviously, we're gonna take this one also, and perhaps that one and that one. So we're gonna we're gonna drag them and then press Alt, which will make a copy, and then you can let go, and then you have a copy. So we can make this, let's say, block select one. And if you enable that, you probably won't see anything right off the bat, and that's because it's right down here. It's been overlapped by everything. And if your curve is somewhere like to the sides here or something, make sure that your step is set to 0 if you want to see right beneath it. But I think I will set this back to what it was, 80 in my case, so that we can actually work on it. Oh, I have to disable that. So we can actually work on it and focus on that one. Okay, so with that said, we have that, and we have our main columns, which is this one. So I'm gonna copy that also from here, and probably should put the path to this one. To enable that, you will see the columns over there. Should probably do this instead so that we can have a clearer. Okay, so we're now missing the secondary columns, and we have that. I think it's this one. Yeah, judging by the looks of the outline on the bottom, it is this one. So what I'm going to do is I'm going to create a curve component, connect that here, and I'm going to name it block one secondary columns, something like that, something descriptive. And I'm going to hide the wires because I don't want to see the wires unless it's selected. I'm going to put it right above here, something like that. Okay, so now what we want to do is we want to move these curves right at where block 2 start, which is the top of block 1. The same goes for every one of these. And to get to the top, we actually have to use our floor heights and the number of floors for not block 1 but block 2. So we can actually copy floor height, and we're gonna copy also our multiplication like that. And let's grab our block 2 floors. So we can shift all the way, Control Shift V to paste it in the center of your screen. The reason why I grabbed block 1 is because in block 1 there is a value, and that value happens to be the top of where we want everything to be. So for example, if I do a move, and I'm going to actually create a plane, because then we can use an XY plane that will be on top of here, because we can then use that as a projection plane to project basically everything onto that plane. Or you can move it with the same vector here, which works the same. So I would say use whichever method you're comfortable with. But let's actually move this up and see if we do have the right height, which I suspect we do, but we can always check. So we do a move. We have to move this one. Looking at this, I might ungroup this for now. But actually, let's move. What's this? That's the column. Let's move that one. Just gonna hide it. Oh, now I have to probably turn on to the side view, and you can see it's highlighted green on my screen. Hopefully through YouTube compression you will still see it. But this is the height of where our curve should be. The only thing is shifted, but we shifted that with a temporary shift. So if you want to see right on top of it, you can actually we can do that now. Since it's on top, we'll probably see it. Though it does take some time to move all these geometries. There we go. And should I leave this on? Probably should. I still have enough space on my screen. I'm gonna keep that for here, and I don't need this panel anymore because I know for sure this is the right move that we need. Okay, with that being said, I'm actually gonna move that one also. I'm gonna disable that. So now that I have all the previous column from block 1 onto the same level as everything else, and now I'm actually going to ungroup my, oh, these are already ungrouped actually. So let's do a list item. We have 2 branches, and each branch has 2 items, which corresponds to the short curves, 2 curves, and the long curves, 2 curves. So what I'm actually going to do, I'm going to actually explode the trees. So if we do explode trees, which can be found under set trees, explode trees. And the nice thing about explode trees is I can actually, well, automatically it gives you 2 output, but if you have more, what you can, it will turn yellow actually if you have more curves, more data branches than what it's actually showing. You can right click on it and match outputs. That will give you a long list of all the trees that you have. So if you have like 1,000, I would not recommend it, because then you will have a component that's, well, very, very long. Okay, with that being selected, I can actually perhaps simplify this a bit, because I don't need the other 3 branches. So let's see, if I select the first curve of the first branch, it's actually the short one. The same goes for the other one. It will select the outer curve basically. I can actually remove this one for now. What I want to do now is to say, okay, I'm gonna find a way to say, hey, are these curves belong or in a position where they should be? If its answer is yes, then we'll keep them. If it's no, then we don't want it. Because if you look at our script here, we basically only want this one and that one. All these we don't want because they're not inside our curve. So we're going to make a test for that. We're going to make an evaluation, a sort of filtering process. And the way we're going to do it is we're going to actually start with the first branch, which is this one. We selected the first curve. We're going to do is select the other curve by doing the plus icon here in the list item. And we're going to tween it. We're going to tween a curve. What tweening curves does is it will have two curves as input, and the F is basically it will create a curve that's between these two based on how much it should be, the distance between the two curves basically. So, and it goes from 0 to 1. So basically a 0.5, it will be smack down in the middle between these two curves. So if I connect that, you will see that my curve is now being tweened between these two. You can actually play with this if in another project if you so wish. You can see that my curve now moves between these two. But I want it actually be in the middle, because the sorting process I'm going to be using is I'm going to be using points that are, oh, let me select the bigger one. I'm going to be using points that are in the middle of all my column outlines. And if that distance of the point is very close to my tweened curve, then that means it's a column that I want to keep, which should be all 6 of these and only these 2 at the end. So let's try that out. And where are my, these are my, okay, so I'm gonna do is, let's do a area to get the center point. Actually, that looks kind of lagging, so let me try center instead, which is center in curve analysis. And that just simply doesn't work because, can I input curve to polyline? Okay, that's fine, because we do have slightly curved curves, and center curve just only works with polyline, which is fine. We can use this one instead. Let's save this. Okay, and now we do the comparison. Let's do point closest to curve, this one. We're gonna grab all our all our points. We are going to flatten them because we want them all to be evaluated to this curve. And then we can do a evaluation. And within this evaluation, we can have a look at the d, which is the distance. So as you can see, there are a lot that it's almost close to 0, and the rest is obviously not close to 0. So we're gonna plug the d into the x, and then we're gonna make our expression that is if x is like smaller than 0.1. 0.1 is big enough tolerance because I don't actually expect any of these to be that off from the center point. So if it's closer than 1, meaning it's very close to my curve, then I would like to keep it, which is true. Otherwise it's false. Then I don't want to keep it. So I'm going to plug that in here, and then what I should have is a true false a list, and I'm going to use that to in my call pattern in order to call all my initial, which should be this one. Actually, I can flatten this one, and then I don't have to flatten all the way down. So I'm going to call that part using my newly created true false pattern. So if I select this, now you can see I have 6 items selected, and they're highlighted all right there. So that's for the first part, for the first column. Now the interesting part is the other column. So we're going to actually do the same. We will do copy all this. We're going to copy that down. We're going to just change that structure, and then we have it, 2 items. There we go. Okay. So with that being selected, now we can start to work on the middle part of our columns. I might hide this. Yeah, okay, let's hide that. I'll leave this to render so that we can also see that. And I might also, no, I don't need that. I do want to see, do I want to see this? Yeah, that should be fine. Now let's open this one, just so we can have a visual of what we're doing. Okay, now we are working on the center parts. The logic that we're going to be that we'll use to make the center columns is it's a follow. Let me zoom. Actually, let's start. Let's start from the upper level. So we have these two start and end columns. What I want to do is I want to have that point right there. There are two things I want to do. The first thing is I want to have that point be projected onto our outer curve. And what I want to do then is I want to shatter. I want to basically snip off the start and the end parts, which is this part, which is this one, the start and the end, so that I can only have a curve that sits smack in the middle between our two start and end columns. Afterwards, I'm gonna say divide my columns into however segments I want. That can be a variable that we can control. And from that segment, I want to say, then I want those segments to be divided back, to be further divided into the width that is the same as our first column or the last column. Doesn't really matter because they're the same thing. So first things first, we want to make a division. Actually, I can't even write that. I probably won't be able to write that very well with a mouse. But so the first thing is we're gonna shatter this into little bits and pieces. And in order to shatter this, we need to identify what is the width, what is the minimal width that we want, what is that width. And with that width, we want to make similar how we've done for the other columns. We want to make these small sections that we will use to cut our curve, and the same thing we'll be using also for that part, for the inner part. And then we just join them together. That was a very bad sketch. I hope you got what I intend to do, but if you don't, follow along, I would say, or skip back and then try to rewatch that part. So first things first, I need to have a center point projected onto my outer curve. So first things first, I need to select my outer curve. I think I already have it selected. Which one was it? It was, I think it's this one. It's either the +1 or the I. Oh, it seems it's this one. Okay, so I'm gonna, since I already have this, I'm gonna drag this out. And what I now need is the center point for our columns there. You can do a center right after this, which is also possible. So if you do center on this one, which is fine, but why would you do that if you already have the data and that data sits in here? The only thing we need to do is we need to apply our filter, which is our same calling pattern. Remember, we made the calling pattern based on the distance, and that comes from the same curve. So what we can do is we can actually do the same, apply the same calling pattern for our the point that we're projected on top of it. And you can see that we have now the exact same point as if you were to do a area that you can apply to this. So we're going to be using this one because it's slightly less computational intensive, because the area can be quite heavy if you were to do it for a lot, but for that just two column, it's very much acceptable. So it's up to you which one you feel more comfortable with, and either one is fine. And now what we're going to do is we want to drag this point to our curve, which we're going to be using the closest point to curve component. And the curve is obviously our outer curve that we've filtered out here. We can do that. And we're going to be projecting our end curve to those, and we're going to shatter our curve based on that information. So now we should have three curves, which is this one. And how the shadow works is because we have shadows at the end and the start, it only leaves us one choice to find the middle, which is index number 1. Because if you know the start can be either end, doesn't really match. doesn't really matter which one. So let's say the 0 is 1, the bottom is a start, which is 0, the middle is always 1, and the other one's 2. Doesn't matter how you turn it, 1 in this case is always the middle. So if you type in 1 for the index and do a list item on top of it, type in the 1 in the list item, you will always get the center point, the center curve. So with that being selected, we can now do a curve division. And let's make it a parameter. Let's say minimum 5, a maximum of 15. We're gonna call this secondary columns. Yep. And let's set that to 10. And let's drag this all the way back there because that is something that we can change. And now we have our curve divided. So now the other thing we need to do is we need to find out what is the width of our columns. And to do that, what I want to do is I want to find out exactly this width, because there can be a scenario where right now we've said, I think that distance is what, 3 meters, I believe, or 3.5. But what if you set the balcony depth to like somewhere almost to the edge, which, I mean, it's a parameter. It's not a balcony anymore because, well, you can't really walk there if it's that small. But that would mean that this part of the curve, the length, is going to be a lot smaller, and thus can make our script can break our script, can make our column this small. So we're going to find a way to say, I want to use only that curve and always that curve. And there's one way we can do that. We can say the curve that is smack, let's say the distance of that curve is within a very small fraction, small tolerance within our outer curve, then that's the curve we want. I'm not sure. I hope you got what I mean. But if you don't, I'm going to explain it by showing you. So let's explode our curve, and we're going to, well, do we need both? We don't need both. It doesn't really matter, because there's only one curve that we're going to be selecting. We're going to do a CRV evaluate in order to get the center point of our curve. It doesn't really matter which point you get on the curve, but definitely not a 0 or a 1, because then you might have conflicts. Because the reason is, let's reparameterize that so that 0.5 is always the center. Now I can say the point that belongs, the center point that belongs to each of these exploded curve, I want to find the point that is smack down in the overlap that sits on top of my curve. That's the curve that I want. So now I can do a evaluate command that test for point closest to the curve, which I probably just copy this one instead. And for this reason, I can actually reuse my the curve that we filter out. Do keep in mind that you use the unshattered curve, because there is the possibility, or the computer might think that, hey, this point sits right at the edge, so is it, what's distance? So I would recommend using the one that is not shattered, and we use that to test all our points. You do have to flatten this because we don't need both of the shortest curve. We just need one, and we know they're both the same. So with that being selected, what we can do with the distance, we can actually apply, I think, this one. Yeah, actually we can apply that one, because we want to say if the distance is very small, in this case 0.1, smaller than 0.1, we want to keep it. Otherwise, we don't want to keep it. What I hope to achieve with this, we end up with only 2 curves selected after we call them, of course. So we want to call the shatter curve, not the points, but we want the curve. Oh, in that case, actually, it's smarter to flatten right there so that we know that we're working on a flattened list from the start. So we can actually flatten that part, put that into the L, and then this one into the calling pattern. So now I have two curves, basically those and those. And at this point, it really does not matter which one you select. They're both the same. So I'm going to do a list item, and I'm going to do length to extract the curve length. And this will be our column width that we're going to be using, which is 1.2 meters. Not bad. And the way we're going to be using that is we have, let me enable that again. We have our point shattered, or not shattered, divided. And actually get rid of this because I don't want to see it. We have our curve shattered. Oh, why do I keep saying shattered? We have our curve divided. And each of these points actually represents the center point of our column. Not the center point, but the center point that is on the outer side, which is on this edge. And what I want to do with that is I have the distance, and my curve is not reparametrized, meaning the t parameter can go up to above 1 or basically outside the range of 0.1 because it's not reparametrized. And that's very important that we do not reparametrize that curve, because we want to say the half. Let me draw that again. We want to say this is the center, and I have the width, the total width of my curve, which is something like that. I want to say the half of that plus this number is going to give me something a distance like here, and I can do the same for the other side, and those combined give me, well, the width that should be our column. And we can actually when we have those two curves, when we have those 2 points, we can actually propagate that to the inner curve. So that's secondary, but let's get this thing, let's get our list of shadow curves first. So the small section that I mentioned in the beginning, and we're going to do that with a evaluate, and our evaluate formula is the width, which is going to be in our case an x. Let's put this in comma. The half of x plus whatever value that is in the t value that correspond to each of these points. And that's basically it. That's basically our formula they're going to be using. Put that in the F. The X is our column width, and the parameter. One thing though, notice how, let me enable our column. Notice how the start and the end column are also in it. So you do have a choice here. The choice is, do we just eliminate them? Or do we say, let's not process the start and the end, and then we reuse this part? So both methods will work. Both will give us exactly what we want. The choice is basically up to you, which one you feel more comfortable and which one you feel more logical with. Basically, it doesn't really matter which one you go through because the end result is going to be the same. Actually, let's save this for now. But for simplicity, what I'm going to do is I'm not going to be remaking the end and the last column. So what I will do is I will actually eliminate the start and end point from this component. But we're not going to be using the point. We'll actually be using the parameter. So we're going to be deleting not using the start and end parameter. And one nice way we can do that is we can use a double calling. Let's do call and call index. We're going to keep calling the index at 0, which is the start. So let's start. For visualization, I'm going to call the point, but in the end, we're going to be switching to the t. But because the t is not visually represented on the viewport, I will show you with a point and how that looks like. Let me disable all that first. Actually, I want to keep the line. So as you can see, with the first point being called, let me draw that up here for you. And it's going to be this one, and why is it black? Going to be this one, and the next one is going to be that one. So I should keep that. Okay, so observe how the magenta point is being deleted because that's where the point starts, and I say call index 0, which is the start of the point. And I'm going to copy this actually again. I'm going to recall this also at index 0, but I'm going to right click on L and reverse it. So now the start has shifted to that side, and it so happens that I'm also saying delete the start point. This double culling is handy if you really quickly want to delete the start and the end of a list. You can also put this in a cluster and then use that in all your scripts. I think I've also written a Python component for this, but I'm actually not sure if it's, oh, it's right. Oh, it's still here. Oh, it's actually a cluster still. My bad. But that is these two you can basically use it in that way. So as you can see, the cluster that I made is actually very outdated because this uses a lot more component than it needed, because I only need 2. And for some reason I've created a lot more components in my cluster, and that cluster I think was made like, could be in 2013 perhaps. So very much outdated. And this is the way that I use now in order to quickly filter out the start and the end. And if you want to retain the order, you can actually reverse this so that the start we reverse back to where it should be, as in the order of the list. Okay, with that said, we have our points, and like I said, we're not going to be calling the points because we don't need that. We need our parameter. So if you plug a parameter now to y, we should have a nice list of parameters that is minus the half of our column width. So what we can do with that is, actually we need the other half. Now we have this one half. To get the other half, I just copy our evaluate command, and I'm gonna give here. You can do it either way. One way is you can copy the formula and then just change the plus y to minus y, or you can do a negative on the width of the column so that it becomes minus x divided by 2, which will give you a minus, a negative number. Negative plus a positive number will be subtracted. So I'm gonna do that instead because it requires one panel, and I want to keep my panel usage as low as I can actually, because those are more like manual input. So the less manual input, the better. So with this, what we have is a list of parameters that we can merge together, and I'm also going to put in a sort in here just in case to sort the numbers. I'm going to hide all that, and now I'm going to do a shatter from my shattered and filtered middle curve, and I'm going to apply it to the K because there's nothing going to the A and it makes no sense to do the A. And now I have the shatter curve, and I have how many? 19 values in here. And if you remember correctly, this is exactly now the method that we used in block 1, which is this one. We're now at this point. So the only thing we need to do is we can copy our true false culling and apply it to that one. Let's see if we've got the first one on the first try. And we do. Because if you disable or invert, you basically get the space that is between the column, but that's not what we want. We want the column width themselves. So now that we have that, what we can do is we can propagate that to our where is it? This one, which is the other curve. Let me also extract that out in this way and display that. You don't need to shatter this one because we don't. We have the data for the shattering already, which is here. So what we can do now is we need a way to copy this parameter here. Now you may think like, okay, can we just not like shatter in this way? Well, unless your curve domain is the same, then it might work, but I'm actually skeptic that this might work, but we'll see. And it doesn't work. And that's because the curve domain is different for this curve than our outer curve. So this method will not work, so I'm going to delete that. what we will do is let's try to get points. Let's try to get ZRV evaluate. Let's try to evaluate our main curve, which is this one. Oh, this one. Using the parameter that we have, so that we have the points. And now we can say point closest to curve. Closest to curve. The curve is our inner curve, and the points is the point that we just made. Let's move this a little bit here because we will be using these components again, because now we have a parameter that's belonging to our inner curve, so we can actually use that to shatter. So let's plug in the curve, our inner curve to C, and our new T here, and there we go. Now we need to merge them together like we did up there, and then we say merge this one and that one. We don't need the third D. We do need to graph these in order to get them into groups of 2, as you can see here. Do we need to simplify? Oh, actually, I don't need to, because I don't really need to see a nice tree structure at this end. But I do need to flip one of these curves, because otherwise you get the same problem of cross-sectioning like that. Exactly. Let's flip one of these. It doesn't really matter which one you flip. One of them just needs to be flipped. And remember to put the curve connection type to position so that they make straight lines. And there is our curve. The last thing we can do is let's actually merge them all together. Let's flatten this one. I don't need that one to be unflattened. And let's drag this to the beginning. Let's combine all our columns now. I think this one is the ends. I don't know if I should combine. Yeah, we can combine those, doesn't really matter. So now I have, how many should I have? I think I have 11 column and 6, so I should have 17 values, which I do. Actually, let's reflatten that, because I don't need to have the tree. If I do want the tree to be separate, I can use an entwine instead. But I don't foresee, for now at least, I don't foresee the need to do that. So now what I can do is copy what are these? Oh, those are curves. So I can actually copy all that. Actually, let's drag copy this. Whoa. Yes. And the direction, let's disconnect it for now. Because that one is, I believe, the floor height, isn't it? Oh, no, that is actually our, now we can get into the part here finally, is the height that is our second block, which is the floor height multiplied by the many floors we have. So I can actually copy the Z value here and make that into a Z and drag that a bit here. Let's make it a panel so we can see what the number actually is. 158. So we're going to put that into our extrude. And those are our columns. Actually, we can how do we do it here? We merge even more columns together, so I can actually do that also. I'm going to do a double merge. The reason why I do a double merge is I actually want to keep this, and we do need this, because remember we've also separated our secondary columns, let's say, from the rest, because we will be using this one for our third block. And I think these are the main columns. Yeah, those are the main columns selected. So I just need to drag it all the way up there and plug that instead. Something went wrong, and I believe I know why. Well, our column is starting from the all the bottom. We haven't moved it up yet. So now what it does is actually extrude it, but extrude it right there, which is overlapping with our first floor. So we need to quickly move that up using the same Z value. So we can actually replace this one to here and move B into our new move component to move it up. And there we go. There we have our column for the upper level, and now we can actually do the same for, what do we miss? We miss our core. So, and our core derives from the inner arcs. So I think that one is balcony depth, main outline. Is it the main outline? Nope. It's main arc setting out. Obviously not. It is this balcony depth. So we can actually copy this, copy that one, copy this one, this one, this one, and this one. So let's copy that down, and we just need to change the index to floor number 1. There we have that one, and now we can say boundary. Oh, we do need to move this first to our appropriate level because these are all at the bottom. So we can actually do this instead. We don't move it the same in the same Z value. I'm gonna give it a boundary surface. I'm gonna actually move this all the way up here, and I'm gonna copy this color here so I don't have to use it. Move it down, and the value you should extrude is the same as the column height. And there we go. There we have our core, and now for the floors, it's the same thing, though we do need to, these are the floors that we use, so we can copy this. We use green apparently, and the height of the floor, so we can actually, let's say it comes from this one, which is a multiplication of the amount of floor to skip. So we have minus the floors to skip. This should be floor 2, and that it multiplied with the floor heights in order to generate a series that we can then use for our move. And we're going to copy all that. We're going to copy this. We're going to copy this one also. So let's copy that first and see how far we can get. This one. Okay, floors to skip number 2. Do we need to skip floors on the second level? I don't think so. Let's try 1 because we might have to skip the first floor, otherwise it will overlap. But this is definitely not 1. So I might have to disconnect some first because it's actually doing calculations. This one is doing calculation based on the old tower, which we don't want. So what we're going to do is we're going to replace these. And what we've done here is actually the subtraction method that we use in order to get rid of the, so if I enable this, in order to get rid of the column overlap. So we can actually do the same here. So the thing we need is actually the main outline, which I do think is this one. So the main outline will be subtracted. Let's put it in this one. Oh, this is not going to go well because it's looking at way different data. It will be subtracted by all our column data. So that's one. And I should move this a little bit here. Oh, one thing I forgot is they're not on the same plane. That's why it's not subtracting. So we need to actually, I might send our move a little bit more earlier. Let's say here already, and then we can plug this one here. So we move it up to the level where level 2 should begin. And then we do all our processing there. So that means that we need to get rid of this one. We need to replace that strictly directly with that. And without me doing anything, it already made my floors, except that I have one too many. But this is our, let me get back in this one. Like that. Okay. This one comes from this. I think I might have to pull this up a little bit more in order to make the lines a bit flow a bit better. These come from my floors, and it seems like I have one floor too many. Well, it's not floor to skip, but floors to skip is actually doing the first one. So if you say like 5 floors to skip, it will skip the first 5 floors. Like that. We are skipping the first floor because the first floor is going to be at the bottom and it will overlap with our top floor of the first block. But what I see here is that we have one floor too many, which is this one. So we are actually going to be saying the number that we want, not +1, but actually just x. Since from the bottom we I think we have +1 because we needed that extra roof column, roof what do you call that? The roof floor. Let me see if I can enable this one because I think we're missing, still missing something. We're missing to get rid of the core. That's why you see this double surface happening here because we didn't put the core outline in order for it to be caught, and that comes from this one. So we can actually drag that one, combine it to that. It's gonna be a little bit more heavy, but in the end you should get a very nice non-overlapping surface tower. Let's keep this up there so that it's a little bit more aligned. Something is still connecting to that one. I wonder what that is. Oh, actually, now I see. This one was plus X because, well, we do need that. We were actually looking at the wrong extrude heights. Which one is this one? Floor thickness. Can I have a floor thickness from here? Or maybe it's not actually. The floor thickness doesn't control that, to be honest. Do I even have a floor thickness in here? Floor height, floor... Oh, we have double the floor height, so let's fix that quickly. Well, obviously it's not block 1 that we need, it's block 2. And the floor height, we already have it, so we're gonna put all these to floor height over there. Gonna get rid of that. Move this up a bit to make it a little bit more space. And the floor height is going here. Nothing's going to change because it's the same data, except that we're now sort of like disconnecting that line that we just saw from the rest. So let's have a look at our final parameters. No duplicates, secondary arc, secondary column, floor thickness, depth, and secondary setting out. Don't we have it? The arc setting, oh, that's different. But if you notice something duplicate, you can actually just call this duplicate because they all come from the same source, so they should be the same data. Okay, well, the bottom part is a bit scarce actually. It's a bit empty, but that's how you do it. And let's actually copy the name also, and just call this block 2. Put this in a nice group, maybe in a different color actually, like that. Okay. All right. This is another long part. Well, the next one should be relatively faster because we already have the same setup, and the part that's above actually do follow the same. We can let's experience copy this whole thing and let's change the parameters so you can see how fast it is to just get the top part, the last block basically of our tower. So with that being said, I'm going to end the video here, and I'll see you in the next one.